Very good morning, students. Today I am explaining the wave optics, that is a revision class. It's a continuation class. In that, so last class I was explained that one concept of wavefront and spherical wavefront and also Huygens statement of Huygens principle. Again, using the Huygens principle, two derivations are there. That derivations now I will be explaining. So that is the first one. We are going to see that using Huygens principle, show that angle of incidence is equal to the angle of reflection, angle of reflection during a plane wavefront, during a plane wavefront reflected by a plane surface. Plane wavefront reflected by a plane surface. Reflected by plane surface. This is the one question. So this question it was asked in 2019 and also it is given in the model paper. So March 2019 and in model question paper also it was appeared. This question. Okay. So model question पे बे क्या है आया है. तो यहाँ पर क्या है एक प्लेन सरफेस बोल के बोल. So as we are knowing that reflection means what? What is a reflection? So reflection means when a ray, incident ray, when it is fallen onto the surface, it is get back to the same medium. इसको हम क्या कहते हैं? So reflection, the phenomenon of reflection, you can see that. According to this one, when there is a law of reflection will be there, and in that law of reflection, we are going to say that the reflected, the incident ray, the reflected ray and normal to the point of incidence all lie in the same plane. So that is this is the one first statement will be there, and second one, the angle of incidence is equal to the angle of reflection. That is angle I equal to angle R. So here using Huygens principle show that angle of incidence is equal to the angle of reflection. Okay, it is equal to what? Angle of reflection during plane wavefront reflected by a plane surface. So it was asked in the question 2019 and the model question paper it is given in the model question paper also. We will draw this diagram. We will draw the diagram. This is the diagram. This is N is the one surface. N is on the surface. You can see that N is on surface. So here we are considering the one incident plane wavefront and another one we are going to see that reflected plane wavefront. Incident plane wavefront means this is the one incident ray. It is falling at this point, and also this is the one incident ray. It is also falling at this point. So perpendicular to this one line drawn. This is we are going to say that plane wavefront. So this we are going to call the incident plane wavefront. इसको हम क्या कहते हैं? Incident plane wavefront. Incident plane wavefront we can call it. Incident plane wavefront. And now we can see that there is one reflected ray. So that reflected, so we can take like this way. So if you are drawn here on perpendicular to this one, this is on straight line. This is angle of incidence, the angle of this is I, you can call it. So this is the reflected. This is what we are getting. No, this is the reflected. Here also we can see that. So again, if you join this one to this point, so this is we are going to call reflected reflected wavefront, plane wavefront, reflected plane wavefront, reflected plane wavefront. Okay, so these 2 points we are going to see that one is the point is A to B and C to this is E. Okay, so A to B and C to this. So this is the MN is we are going to see that MN is called reflected surface. Answer we can write down how we are going to say it. So let in figure we can see that MN is called reflected surface. MN is the reflected surface. Okay, so this AB, it is called AB is the, so this one is the incident wavefront, incident plane wavefront, incident plane wavefront, and EC is called reflected plane wavefront, reflected plane wavefront. EC is called what? Reflected plane wavefront. And this I is called angle of incidence, angle of incidence. And this is R, it is the angle of reflection, angle of reflection. Okay, so now see this one ray when it is incident to this point, that time this ray it is at the B position. Okay, so अब ये एंगल ऑफ इंसिडेंस प्लेन सरफेस MN को टच हुआ तो यहाँ पर क्या है B तक आके रुकता. Still it is in the water, it is not touched to this C position. So what happens to this plane wavefront? It will be moving like this way. So it is reached to this point. So it will get down certain distance. That is BC. BC, it is the distance traveled by the light. The distance which is traveled by the water, light are B to C. Okay. So BC equal to, okay, the distance BC equal to V into T. Velocity of light into T. Now see the distance equal to BC equal to VT. So this is what we are going to get now. Equation. So this is from the what? Incident wavefront. This is from the incident wavefront we are getting. Similarly, when it reaches to this point, that point after this one reflected ray is moved to the E. Okay, so then the distance traveled from A to E, that is the reflected wavefront, it is traveling from A to E. This is the incident wavefront. So similarly we can take the water. Similarly, AE equal to V into T. This is equation 2 we can write. Okay, so now there are two triangles we can suggesting. One triangle is ABC. Okay, ABC. Another one triangle it is the AEC. Okay, so from figure we can see that there are two triangles. From figure, okay, so triangle ABC and triangle EAC. Here we can see that angle ABC and angle AEC both are just 90 degree only. This is a perpendicular right angle triangle. So there is a perpendicular or right angle triangle we can call it. So from this therefore, so angle ABC equal to AEC equal to 90 degree. Okay, so these are two are 90 degree. So AC is common. AC is common. AC is common. Common side. Okay, AC is a common side. And from equation 1 and 2, from equation 1 and 2, So we are getting that BC equal to AE. So see, this is what, this is also side, this is the side angle, side. Using the postulate of side angle side, so we are going to say that these two triangles are congruent. These two triangles are congruent. So from SAS postulate, okay. So this is I will write down of course. So here you can see that from above this one, triangle ABC, it is congruent to triangle AEC because it obeying the SAS postulates. SAS postulate यूज कर रहे हैं. कौन सा postulate यूज कर रहे हैं? SAS postulates को हम यूज कर रहे हैं. तो अब ये क्या होता है? Therefore, angle R equal to angle R. Whatever the angle of incidence is there, no, so that will be equal to angle of reflection. Two interior angles are same. 2.6. Okay, angle I equal to angle R. So show that angle of incidence is equal to angle of reflection. Angle of incidence is equal to what is that? Angle of reflection. We have shown this one. What the thing, sir? Okay. The 2.6 derive Snell's law of refraction. Derive Snell's law of refraction. Derive Snell's law of refraction using Heisen's principle पे ऐसा पूछा है. So this way also they may going to ask in the annual examination or derive the Snell's law of refraction. Okay, so derive the water. So Snell's law of refraction. So you know that what is a refraction? Refraction बोले तो क्या है आप लोगों को मालूम है. What is refraction? Refraction means so when a ray travel from one medium to the another medium, so the ray is bend either it is towards the normal or away from the normal, depending upon the how the ray is passes from rarer to denser or denser to rarer. So the ray will be get bending. अब क्या है एक रे क्या है bend होता है तो उसको हम क्या कहते हैं? So that phenomena is known as refraction. वो phenomena को हम क्या कहना है? Refraction कहना है. Got the thing, sir? So here using Heisen's principle we have to derive the Snell's law. So Snell's law, it is the second law of refraction. The first law, as we are knowing that the angle of incidence, the incident ray, the reflected ray and normal to the point of incidence all lie in the same plane. This is the one law we are going to know in. And second law, it says of sine of angle of incidence to the sine of angle of refraction is a constant. That is sin I by sin R equal to n. ये हमारे को प्रूव करना है. So we have to derive that equation using the what? Heisen's principle. N equal to sin I by sin R. Sin I by sin R क्या है? क्या है? Snell's law का statement है. So हम वो derive करना है. So we have to derive that equation. See, this is the one. Mn is the one. Refracted surface. Mn is the one. Refracted surface. This is we are going to call the refracted surface. Okay, this is one refracted surface. This is the normal to the incidence. Okay, so this ray it is follow to this one, that is A point. This is the one A point. They follow on it ever. Still the other incident ray it is in the air only. So this will be the what? Angle of. If I draw the perpendicular line to this one, this is the what? इंसिडेंट प्लेन वेव फ्रंट. ये क्या है? इंसिडेंट प्लेन वेव फ्रंट. इंसिडेंट प्लेन वेव फ्रंट. Okay. So as we are knowing that when a ray travels from one medium to the another medium, this is the medium 1, this is medium 2. When it is traveling from one medium to the another medium, the ray will be bent towards the normal. When a ray travels from rarer medium to the denser medium, this is we are considered as a rarer medium, and this is denser medium. This is the rarer medium and this is the denser medium. So this, it is getting the what? A refracted ray. So this one we are going to see that it's a refracted ray. This is also what we are going to see that it's a refracted ray. Okay. So from A, it is the center. One circle arc if you are drawn. So then if we take this is the one perpendicular to this one, the tangent to the this ray. So then we are getting the one wavefront. That wavefront is called refracted. This wavefront we are going to call the refracted plane wavefront. Refracted plane wavefront. This is angle of incidence I. Okay, so ये क्या है? Angle of incidence है. This is the angle of refraction. So this is I. Whatever the angle of refraction is the R. That will be the what? R. So answer we can write down. Answer in figure. What we are going to see now? In figure we are going to see that Mn is the water refracted surface. Mn is called refracted surface. Okay, refracted surface. This is A to B and this is the C. This is the E, we can take it. So here AB is the incident. AB is the incident plane wavefront. Incident plane wavefront. Okay, incident plane wavefront. AB. And then EC is the refracted plane wavefront. Angle I is the what? Angle I is the angle of incidence. Angle of incidence. And then angle R, it is called angle of refraction. Angle of refraction. Okay. R, it is called the angle of refraction. So this is the angle of incidence. This is the angle of refraction. We are going to see that. Okay. So now we are going to derive this equation. Means the ray is traveling from B to C. That is BC. We can find the distance. The incident ray. The incident ray travel the incident plane wavefront. Plane wavefront. So travel a distance that is our DC equal to V into T. This is V1 we are going to take because it is in the first medium, so that's why V1 we are going to take it. V1 into T. This is the equation. Similarly, okay. So in plane wavefront also we can say that the refracted wavefront, plane wavefront. Refracted plane wavefront traveled a distance AE the refractive index is the ratio of the velocity of first medium to the velocity of the second medium. So the refractive index n equal to v1t divided by v2t. So this is, we can see that v1 by v2. So v1 by v2. This is equation 3. That will be what are equation 3. So now we are going to see that this is the one triangle ABC. From triangle ABC, triangle ABC, okay, side I equal to, that is opposite by hypotenuse. Opposite is BC. Okay, opposite क्या होता है यहाँ पे, क्या है, इस एंगल का BC होता है. Hypotenuse we are going to see that AC. Okay, AC. So again from triangle you can see that triangle. So AEC triangle से क्या होता है, sin R equal to, so that is opposite by hypotenuse equal to. So this one we are going to see that AE divided by AC. Sir, this is equation 1. This is equation 1. 2 minutes. So take the ratio of so that is sin I by sin R equal to, so this is BC by AC divided by AE by AC. This AC get cancelled. BC we are going to see that sin I by sin R equal to BC by AE. BC value is V1 into T divided by V2 into T. T get cancelled. This is V1 by V2. This is V1 by V2 means it's a refractive index, that is N. So therefore sin I by, here I will write down, therefore sin I by sin R equal to. So this is the one derivation. This it was asked in so many years, it was asked. So model question paper में भी पूछा है, and it was asked in the year 2017-18. ये देखो, ये मार्च 2017 और मार्च 2018 और मॉडल क्वेश्चन पेपर में भी ये क्वेश्चन है. तो प्लीज as much as you have to be practice it. Okay, so I'll stop here only.